Semiconductors have become part of our life.
So this is going to grow to a 2x, 4x level in next decade very easily.
With all the latest and the greatest tools, they should also be exposed to what the industry is talking about.
There has to be a year dedicated for the semiconductor technology itself.
People know what are the challenges for manufacturing.
It's about $530 billion industry global level.
Students will start getting ideas, where the bottlenecks are, what I need to learn about.
There is a sixth course which is only a project where the student can take up any project of his or her choice and study whatever technologies are needed around that and build it up.
More like an executive program from the academia side to train the laterals, and then center of excellences for the freshers.
Not just contributing over there, but to get themselves better enabled.
The students who are in academia, they have to take up the challenge that we have to make sure our country is getting that semicon industry which Southeast Asia already has.
Government came up with programs like Special Manpower Development Program.
And that has opened up a huge innovation in the industry.
There's a co-package optics chip coming out of India, patent in India. The process know-how would be done in India, and then a line would be set up to do co-package optics.
Start putting them to really responsible roles.
Now we are at the start of beginning of the new era.
Third year you spend in the center of excellence in your college.
Education is just a qualification criteria, but academia is totally different.
Our basic needs are roti, kapda, makan, and now with semiconductors, it's like roti, kapda, makan, and chips. That's our basic needs.
Tired and frustrated of corporate artificial and plastic talks? Are you frustrated with unskilled YouTube gurus telling you what to upskill, how to cross-skill when they themselves don't have any tech background? So here at Titan Stock, we call industry stalwarts from across multiple industries and have them share their views on what they look for in lateral candidates and in freshers. So these are people who've been there, done that, and who are continuing to do. So these folks are going to give you their raw, unfiltered opinion on what they want and what they look for in a candidate and how you can prepare. We will talk about how should a lateral approach every industry and how they should get in, and how a fresher should kind of prepare themselves so that they become industry ready and more employable compared to just another college graduate. Welcome to Titan Stock. Here we are with another episode, again breaking the shackles of corporate world and talking to you straight from the heart. Today we delve into the industry of semiconductors and networking. So we are here to talk with a lot of industry leading giants here, and so would like to understand from you folks on what is the state of the industry, what do aspiring folks kind of get into, what do they need to learn, and then what do the fresh graduates need to do. And we have Karthick from Vishwakarma as well, who will kind of help us understand what fresh graduates are doing today and how they can bridge the gap between industry and academia. Raghu, CEO of Kaynes Semicon, wanted to understand what are you doing at Kaynes, and how you see the future of the industry in semicon manufacturing.
Thank you for having me here, and it's good to interact with everybody today. So Kaynes Semiconductor basically setting up a OSAT manufacturing plant in India. And this would be one of the first kinds, at least in the last 30-40 years, we all aspired to put a manufacturing plant. I basically come from, with 33 years in semiconductor industry, started my career with a company called Semiconductor Complex in Chandigarh. I was a design engineer, then moved into business. For first 10 years, did chip design, using all the latest and greatest tools at that point in time. Then moved into testing, moved into reliability, moved into AT in SEL, and then went on to start Mentor Graphics in India as a liaison office in 99-2000, and ran it as a country manager for 20 years, growing business, engineering team, people. And then 2017 we got acquired by Siemens. 2019 I left and then went on to work for Tesol Semiconductor for 3 years, and here now I am with Kaynes Semicon for the last 1 year. So our intent is to ensure that we reduce the import bill for semiconductor and hence manufacture in India.
Oh, fantastic. That's great to hear. And then Deepak, an Intel prodigy who is at the forefront of designing Intel's latest and greatest chips. Want to hear from you, Deepak.
Yeah, thanks, Gautam. It's a wonderful feeling to be here discussing with all of you here. Gratitude to VIT for having me here as an alumni of VIT. I'm happy to share my personal views here with all of you And I hope the current students of VIT and future students of VIT find this thing useful. So I passed out from VIT in 1996, and I started my VLSI career with CDAC Pune. And those days, we were designing chips using the schematic entry. Gate by gate, we used to design and enter the schematic, right? So that was long back. So at Intel, I'm having expertise in RTL logic design, architecture development for soft IPs and SOCs, right? And I write IP architecture specifications, mentor design and validation engineers to deliver good quality IP for our internal customers in across client and edge servers and the data center servers, right? That's what I'm doing at present. And so after Pat returned back to Intel as a CEO, right? Intel is delivering five uh, manufacturing process technology nodes in just 4 years, right? Instead of 10 years. So under his leadership and 100,000 plus exceptional engineering talent at Intel, Intel is transforming itself from CPU company to multiple architecture XPU company in order to meet the demands of the compute and to advance the future of the compute, right? It's also transforming itself from conventional IDM, traditional IDM model to the new modern IDM model, where it is providing foundry services to its customers in the areas of architecture, physical design, test, debug, software, right? It's leveraging its strengths in silicon software system platform, right? And to grab the or to deliver to the massive AI opportunity, Intel is having AI everywhere strategy, where Intel is infusing AI in all of its products across client, edge, and the data center servers, right? So we recently launched Gaudi processor for data center, data center market, basically for training and inference. And to take AI to masses, Intel has recently launched AI PC, where the neural processor unit itself is integrated on the processor, right? So Intel is basically fueling the siliconomy in order to increase the interconnectedness between the technology and the humanity.
Okay, got it. That's very nice to hear and see what Semicon legend is doing to kind of innovate. Thanks on that. So and let's come to the TV man. So the future of TV. So at Ridaex Systems, Naveen, what do you do? And
Yeah. So thank you very much for giving me this opportunity. So I think this is my first podcast, right? So let me give a brief intro about what we do at Ridex. But before that, about me, myself, Naveen Srinivas. I'm the CEO and founder of Ridex Systems India. And at Ridex, we are specialized in manufacturing of future televisions. Now, you might have heard about LED TVs. You might have heard about smart TVs. But have you heard about what future TVs are? It's simple. As the name says, what future TVs are, we abbreviate it as friendly usable, timely upgradable, reverse engineered televisions, which means the TVs that you use today, smart TVs, are not very friendly usable. And we develop friendly usable televisions. I'll give you an example, the realistic example. Let's go to YouTube. Imagine let's go to YouTube and try to search 4K video. In case if you have to search for that over a soft keyboard which is on the screen, you have to tap the arrow keys in your remote at least for 20 to 30 times, right? It's very painful. I come from the space. So this is what we did. We started introducing a gyroscope enabled remote where we have a cursor that can navigate to any pixel of the screen and let people do whatever they want on the screen, like from X0 to Y100. You can navigate anywhere you want. And the remotes are in such a way that they are designed by using gyroscope. They do have quality keypad right beyond them just to operate, and we can use the TVs by using voice commands. So that's called friendly usable. You have to use your TV in a very friendly manner rather than tapping the buttons for 100 times. Second thing, timely upgradable. You see, we buy mobile phones, and the average lifespan of a smartphone is about 2 to 3 years. The same comes into televisions because we are using the SOCs, where you people are the experts in manufacturing those. So these SOCs, you know, they get outdated very often. Their lifespan is close to like 3 4 years maximum. But whereas if a person is buying a TV for his home, then the commitment has to be for next 10 years, right? They buy TVs imagining that they would use those TVs for 10 years, whereas due to technological advancements, we have the TVs getting outdated. That's what we solve by using timely upgradable feature. So what we have done is, in televisions we have divided the television and we have rolled it in such a way that it's totally a modular design. You buy a TV in 2024, by 2026 it's outdated. Then you need not have to change your entire TV. You just change a simple chipset in the TV, and all the features in your TV is changed. That's called timely upgradable and reverse engineered, right? So I come from cybersecurity background, have deep knowledge about networks as well as now into the SOCs. Uh, I have reverse engineered a lot of televisions. I'm telling openly, I've reverse engineered a lot of brands of televisions and found that there are some basic architectural defects that are there. If those are fixed, televisions can be better products, and in fact they can be a two-way communication devices rather than one-way communication devices. And TV, television, that's the abbreviation of future TV, and that's what we are experts in developing. And currently we are in Indian market, and hopefully, and we are putting our best efforts to get into international market in next 3 years. Thank you.
Kudos to that. Thanks. It's you you have a different you're like like a 5 mark answer or a 15 mark answer. You kind of broke through what is future. Okay, now over to Harshad. Harshad, what do you do at Juniper, and what is Juniper doing nowadays? And
Right. First of all, thanks VIT for giving this opportunity. I'll speak a little bit about Juniper because very few people know what Juniper Network does in India, definitely in the engineering community. So, what Juniper Networks build is massive scale core routers and edge routers. And where this devices sits is placed at the Bharti Airtel or any service provider in the world, AT&T, NTT in Japan. And these guys are routing traffic for an entire city or a segment of a city. So these are like massive scale devices. So there is recent device which we are sampling. Okay, the box, the chassis has roughly around 5,000 links working at 100 gigabits per second. Now, anyone who has built a device or a PCB with, let's say, 800 gig links will understand the complexity in building such device, making it work, cooling the system, uh, doing the SI analysis for this system is a huge task. At Juniper, we do the silicon for this device in house. We do the entire PCB design, the chassis design, the cooling design. We have facilities where the chassis are guaranteed that even if up to 6 grade earthquake happens, the chassis will still work. And then on top of it, we have a huge software army of people. We have our own software, own operating system called Junos. In all these 3 layers, I work on the silicon side. So basically, a router, a present day high scale router, made up of multiple packet processing chips connected via fabric device. And I am part of the team which architects this fabric and architects the way a huge scale non blocking network is built. And it's entirely built inside the chip. There's no software component, no CPU on the chip. I've seen 4 transitions in last 10 years, starting from 10 gig, 200 gig, and now going to 200 gig. So it's been an honor to work at Juniper because it has given a huge opportunity for us to just double or triple the scale every time we do a chip, and that involves a huge effort to do that. So yeah, that's what Juniper is into, and that's what I am doing for last few years.
great, thanks, Harshad. That's you know, very insightful on what Juniper does, and the three layers of business that you talked about. Probably not everyone knows. So Karthik is here from Vishwakarma. So he is the head of training and placement. Karthik, a few words about what you do at Vishwakarma and why Vishwakarma is heading the technology wave in the engineering institutions.
Yeah. Thank you, Gautam, for arranging this podcast. So at Vishwakarma, we have around 3,000 engineers currently graduating each year in a variety of disciplines, almost 12 disciplines we have. And electronics and telecommunications has been a core branch in which students graduate, from which students go into the semiconductor industry. So we have had our curriculum also for it, which we have fine tuned to ensure that students who are really interested in pursuing a career in semiconductors undergo all the electives or courses right from the beginning. Whether it is electronic devices, semiconductors, VLSI, and those courses, so that they're ready when they go into the industry. So we have noticed that students, especially in the telecom graduating branches, there are two types of students. One is who are interested in core semiconductors, and the other who are interested in IT. Okay, so we have arranged our curriculum in such a way that students could choose either option and specialize in electives, etc., throughout their engineering curriculum, so that they can land in that particular industry of their choice. And over the last 15 years, one thing special that we have had is an internship program, which we started as a 6-month internship in the final year. But then now in recent times, we have even allowed some of the students to do a year-long internship if they have completed all their coursework, before prior to that, which allows them to spend a lot of time as a student in industry full time, like 40-45 hours every week, along with the industry experts, and delivering the project, so that by the time they graduate, they're actually ready to go from day one. Yeah.
Great. That's a very interesting thing. I think everybody's ears went up when they heard full-time internship for a year. So I want to kind of go part by part, and then first understand the state of industry from, say, Deepak and Harshad, and then go into what will be the future. So what is the current state of the industry, Deepak, and what do you think are the current technology trends, especially in semicon?
Yeah. So no, I would recap little bit into the past, and Raghuji may agree with me because he's longer in this industry than me. So no, going back to the time in 1970s when the transistor was invented, microprocessor was invented, and first chip was built, right? So industry consistently made progress by reducing the transistor feature sizes, right? So transistor scaling that fueled the innovation for about 2.5 decades in semiconductor industry, right? So that was the PC era. I say it was a PC era. Then we moved to PC and networking era, where industry was building complex SOCs, right? Then from PC and networking era to we moved to laptops and the mobile era, where the low power design with high performance demand was the norm there, and that was fueling the innovation in the industry, right? And from the mobile era, now we are at the start of beginning of the new era, where we see lot of emerging use cases and AI, cloud, the connected devices, the autonomous vehicles, e-vehicles, right? So that's the current demand of the market. These are the different market requirements, right? So during the mobile and PC era, the complex SoC that we were building, the methodology that we were using was using the IP reuse, because the SoCs were so complex. Then you want to build the SoCs faster, so you want to have the IP reuse across product to product and across the market segments, right? So EDA advancements in this space, right, that enabled development of complex SoCs faster, right? Now today we have this all these use cases that I'm talking about, that requires us to have heterogeneous architecture, right? So where we have a performance CPU, we have a power optimized CPU, we have GPU, we have accelerators on the same package. Basically that's a heterogeneous architecture, right? So that's increasing the complexity by 100x. And recently, with the current trends, we are hitting the power and power density challenges on the chip, right? So industry is now moving towards more advanced packaging, the system on package, right, using the chiplet based method, right? So this chiplet based method, it's allowing you to have, wherever you require high performance, you can use the latest and the greatest technology node. You can use the latest and greatest technology node and build the chiplet, right? And wherever there are cost sensitive segments, or where you don't have performance as a critical need, you can still use your previously built chiplet on the older technology node. So the advanced packaging today allows you to mix and match chiplets and build the advanced packages, right? So that's one trend we are seeing today. The other 3D die stacking technology, which allows the Faveros allows you to stack the two dilates using the low latency interface, right? So that's another trend. And the chiplet to chiplet, we have industry standard interface defined UCI, which you can use to interface the chiplet. You can have chiplets from one vendor, and you can have chiplets from other vendor, and they can still be packaged on the same package, and you can meet the needs of the market, right? So I see that from PC era to PC to networking era, and to mobile era, and to the current era, the number of and the variants of the chips, the complexity of the chips is growing significantly.
Got it. Got it. So, as in, you took us through the entire, journey of semiconductors. So, and Harshad, on a more futuristic way, how do you think Juniper is adapting to these new technologies that are coming up, and how do you see Juniper leading the way?
Sure. So I'll add to what Deepak said. We have entered a very interesting phase because there was a phase 10 years back where, or 15, for around 15 years, when we went from somewhere around 90 nanometers all the way up to 3 nanometers, right? In some 15 years. And it's going to be very difficult beyond this to scale the technology. So what happened when 90 to 3, we every time you can take the same design, just go to the next node and you just get 2x the performance. May not have to do anything new. But now, because now we have kind of frozen at 3 nanometer, and 3 nanometer is extremely costly, right? Uh, this new chiplet thing has come up, right? And that has opened up a huge innovation in the industry, especially for people like Juniper, who don't own a fab, who are very cost sensitive, right? They are a ASIC kind of a fabless vendor. That's another term which we use. So what we can do is we can we can grow the performance of our networking device by building multiple chiplets, connect them in a package, co-package them, and still achieve the same scale. Because whatever you're getting from just going down to the next node is not available anymore, right? This is also opening up another field where now more innovation may come in the PC architecture. You may design a chiplet which will do a very specific job, and you can go with maybe a x86 or ARM, and if that becomes another SoC or package which can do that. So Juniper, we are exploring all this option. We already have a few devices on the market like that. Again, we don't sell semiconductor; we sell a box which has all this innovation into it.
Okay, so you're riding on the wave of semiconductor industry by packaging it in a more usable and ready to roll kind of a form. So, as in given we wanted to address the talent that is coming into this industry as well. So, I want a couple of founders, CEOs here. I wanted to kind of ask you the question. What specific technology trend is going on in the market right now that people who are experienced want to get into the industry, or people who are entering the industry for fresh should look at, Raghu?
So, thanks to all the technology advancements which Intel and Juniper is doing, um, I would like to go back a little bit and see what happened, you know, 25 to 30 years back. How did we reach here to be one of the best design powerhouse? Right now, in the chip design, we are second to none. Rather, we're the best in the world, right? Look at every multinational which has a chip design to be done, they have a design center in India, and which meant that we are owners of the end to end as a product, which means that we are doing everything in India. How did we achieve this, and what do we need to do more there in a design standpoint? So 25 to 30 years back, there was some phenomena that happened. We just did not reach here to be best in the world in chip design, right? So let me put three people there. The government, industry, and academia. All three came together to do something which is unique. And now when we look back 30 years, oh yeah, we are the best now. Government came up with programs like Special Manpower Development Program under Ministry of IT, which was earlier called Department of Electronics. That program necessitated that there were tools available. The labs were set up in the IITs and ITs and the other colleges. They took this program. Now this is the fourth or the fifth version of the program running, which means that close to 150 to 200 colleges have now VLSI lab set up, have now all the best in class vendor tools available there, which means that students are necessitated to use these tools in the fifth, sixth, seventh, and eighth semester, do projects, do FPGA design, do small designs, and not get into a mode where 20 years back when we used to see students copying projects, now they don't. Now they really get their hands on because labs are available, tools are available. Train the trainers, there are professors who are trained, the lectures who are trained and all that. So, that phenomena changed a little bit. Then second was how did the industry come about? When Ministry of IT started this program, industry also, the three tool EDA vendors like Cadence, Mentor, Synopsys, all three of them came together and did some donation program, did some program with which the tools were available to ministry and they gave it to so the industry came about. What did academia do? Academia made sure that these were deployed rather than keeping it on the shelf. These were deployed, these were used. EDA guys came and supported. Academia made sure that the designs are available. Industry came and supported. Now we have center of excellences in some of these institutes, and this is beautifully working now. So there was a concentrated effort that went about. Now, what do we need to do more? So this is just 150 college, 120 college. But there is a huge ecosystem of more colleges in some of the remotest area, right? Bangalore is self-sufficient, Hyderabad is self-sufficient, Pune might be self-sufficient. But what's happening in Odisha? What's happening in the remotest part of Andhra? What's happening in Gujarat? We need to look at some of those colleges also and see how we could replicate this. Case in point is that when I do still go to colleges to talk about what is happening and stuff like that, there somewhere students are still caught in the bug of software design, get into the bug of app design. So the core electronics per se is waning down a little bit. So maybe we should go to those colleges, tell about core electronics. So students should come back to take these programs, learn BSDL, Verilog, now System Verilog, and then do projects, and then then we'll have the Qualcomm, Intel, and Juniper going there and hiring people. So I think some of those initiatives need to be done, which is why if you look at Minister Ashwini Vaishnav's video, the last video that he released when he announced the fab in OSAT, he did give out a picture about an ecosystem drawing, the manpower development drawing and all that. So he also feels that the government should go back and talk to these people. So I believe that whatever we did in the last 30 years, look at the finishing schools. Two CDAC alumni, they ran a program ACTS to proliferate VLSI. There are a lot of other finishing schools, Maven Silicon, Sandeepini, Veda IIT, and few others were giving these programs for students who came out of engineering college. They took these programs of VLSI, diploma, 6 months, 8 months, 12 months program, and then the industry absorbed them. So should we have a finishing school or should we have these finishing schools move to the colleges is something that we can look at. Now this is the past. What do we need to do in manufacturing, which is now, the wave, which is now India is looking at setting up semiconductor manufacturing. Now there again, we don't have expertise. We don't have trained manpower at all level, at the lateral level and at the engineering graduates level. So some of us have started to look at seeing what do we need to do now to put manufacturing at a level which we did for design. Manufacturing meaning, our colleague spoke about, legacy packages which are there, which are the wire bond technologies which were there, the substrate-based design which were there. So those kind of package, and then I heard co-package optics and stuff like that. So these are two, three kinds of technology from a semiconductor design standpoint. These should be taught now. These should come into the colleges. There should be center of excellences that should be created so that, and we don't take now 30 years, maybe take another 5 years and get into the wave of manufacturing, because this is the need of the hour, which we believe. And some of us have started to talk to colleges and see how do we enable these colleges to look at manufacturing along with design, because that would be a requirement as we move around. Some reports say that 1 lakh engineers are required in the area of manufacturing, because there is Tata putting up an silicon fab and a OSAT plant. There is CG Power putting a plant for OSAT. There is Kaynes Semicon putting a plant. There is Kaynes doing bareboard PCB. So and all these are newer functions and newer areas which would need engineers, to be trained and coached in the colleges and then come into the market.
That's actually a really interesting point. I wanted to kind of double down on that and understand. So when you say challenges with talent, so do you see challenges with more with lateral talent, not being very tech savvy and not being able to ramp up the speed as fast as possible, or is it mostly with the fresh talent that is coming into the industry? Which side of it do both sides are pain, which side of it is a bigger pain?
So both are painful. 30 years back, we didn't have anything. So some expats came to India at that point in time, right? They came to India, or some Indians returned back to India, and they started the design centers. Take an example, uh, Intel came in India much before. TI came to India the first, right? Because Mentor CEO, who was erstwhile CEO for TI Semiconductor, Dr. Wally Rhines, he was responsible for setting TI in India. No, TI came to India doing EDA design and then moved into chip design and stuff like that. But some of the Indians who worked for 30, 40 years, they returned back and set up centers. Along with that, the programs that were done, students got trained and then came in. So it's a mix of both. Here again, the story is the same. We don't have people here on the laterals or on the fresher side. So what we are planning to do, we go to Southeast Asia, because that's a hub of manufacturing. We've gone there. We have partnered with a few technology companies. We are trying to bring them to here on a 3 to 4 year contract. So they will come here, help to set up these manufacturing plant. Look at who did that. All the Indians who were in America looked at Southeast Asia to build the OSAT here, because India did not start, right? So those Indians in America built those centers in Southeast Asia. Now they themselves are looking how to train India and got those. So it's both expats from Southeast Asia, could be the Malaysian national or Taiwanese and Philippines and Vietnamese. We need to get them here for a long term period, so that they bring laterals come in, and then we look at colleges to train. And I'm sure it will not take 30 years, it will take 5 to 6 years to get this set up.
Got it. More like an executive program from the academia side to train the laterals, and then center of excellences for the freshers.
Executive programs are generally pointed towards the MBAs and stuff, but then I would say it's more like a certification program, because laterals have to, people who have design experiences, people know what are the challenges for manufacturing. At least they are designing what could be manufactured, right? So they know the design part. They also know, they might have traveled to Southeast Asia. I'm sure Intel has a big manufacturing site in Penang, right? So I'm sure in guys who are designing the chips would have traveled to Penang, look at how the manufacturing happening. So some of that would work. IIT Mumbai, we started a certification program, a 10-day program for manufacturing. And we are going to do that at multiple times in IIT Mumbai. We are planning to do it with some other colleges as well. So at least some of these laterals can come and learn, and then freshers can also learn.
Got it. Got it. That's helpful. And Naveen, wanted to understand what is the challenge that you are facing, especially as a, as a budding company? What are the things that you face? What are the challenges, especially in the semicon industry, one with lateral as well as with freshers?
Great. So, as we can see, we have experts here who are into manufacturing, right? So, we have someone representing Intel, one from our own Indian, semicon design company, and we have one from Juniper. All of these people are manufacturing for end users, and we are the last people who integrate all of these semiconductors into one final box and give it to the end users, right? So when we are looking at how big the entire industry is, it's about $530 billion industry global level right now, and the requirements of skilled people or the engineers or the technicians by 2030 is going to be about 1.3 million people. Yeah, that's what we are looking for in India itself. Now imagine 13 lakh engineers in different parts or the different variations of the entire semicon program what we have. To get them, I'm sure in an engineering college we definitely need to dedicate a year only for the semiconductor technologies, right? So I'll tell you why I'm telling this because the mistakes that we have done at Ridaex when we started hiring people uh, who were not skilled up to the level that we wanted, right? So imagine we use semiconductors in every board that we use for our televisions, or even the backlight systems of our televisions, the motherboard, logic board, the remote controllers, and infrared sensors, and even the cameras that we use for video conferencing in our TVs, we use semiconductors. And a lot of people are not adapting to the new age technologies today, right? Let's say the freshers whom we are trying to hire are stuck in one single cube. They don't have that exposure towards what's coming every day. What I feel here exactly we need to do is I think engineering colleges need to have a dedicated year specifically to understand more about the in, out, and the peripherals of the entire semiconductor industry. Let's say for we have electronics and electricals and electrical engineering, right? E&E. So probably a dedication of a year there might really help to build this number of engineers that are required for Indian market itself. Right now, what we are seeing is the same. We are not getting any kind of experts. We are having people who are, uh, who have basic ideas, and companies need to train them from scratch to understand what semiconductors are, the applications. Semiconductors are not only the hardware components. We also do have the softwares part where we call it as firmware. So even we need to train people not only towards the hardware fab and the design, but also towards building right firmware for it, because that's the life of the entire, right? So I'll tell you the real time challenge that we have actually faced about 2 years ago. We wanted to do a major upgrade in our televisions. The chipset was there, but unfortunately, we didn't have a right kind of skilled people in our organization to do that particular upgrade, because the chipset was already supporting, but we didn't have people who could write a perfect firmware for it to be executed, right? So students are stuck in a box. They are looking at only the academia. I mean, to be very, very honest, internships is what you're telling. What does 3 months internship teach them? Nothing. A lot of students come in for an internship just for a certificate. I'm being very bold about it, right? Just certificate. But what you people are doing is really great. I mean, 1 year of internship is that's going to prepare a lot of students for what industry standards are. And once the internship is done, then we can hire them as freshers and start putting them to really responsible roles. So I feel uh, teaching after that, internship has to be done in a right way, and then we need to bring them on board to the main positions in the organization. We face these issues, and we wanted to solve them. To solve them, we need support not only from the government. Also, students should be very much interested that, you know, what China, what Taiwan, and what other Southeast Asian countries did during 1980s. The same thing has to come here in India right now, and we the entrepreneurs should take up that challenge. The students who are in academia, they have to take up the challenge that we have to make sure our country is getting that semicon industry which Southeast Asia already has, and they need to brush up their talent every single day with the latest available knowledge. It's very important for them. So don't aim for certificates. Get on grounds, do your research, and then do internships at a very good organizations where they can teach a lot. Then get on board. You have a wonderful industry to explore and learn from.
Kind of, summing it up, what you're saying is you're playing a catch up race which is 40 years late. One second, what, adding, kind of summing what Raghu and you told together. So basically, what you're saying is 2 years in college enough. Third year you spend in the center of excellence in your college. Fourth year you spend in the company. At least you will be employable by the end of it. Because I also like a very big proponent that education is different from academia.
Education is just a qualification criteria, but academia is totally different.
I totally get it. So, Karthik, coming back to you now, putting you in a spot, like we all of us are one team, and then we want to, ask you, what is Vishwakarma doing to bridge this gap? How is Vishwakarma different from, any other random engineering college that was started last year?
Yeah, answering Deepak's point that students coming for internships and not performing or just trying to work for a certificate, I do agree that perhaps such a tendency may be there in general. What we have done is ensured that the internship program in the final year is a credit course and it has multiple evaluations. So the way we go about doing it is there is one teacher internal appointed, and also in the industry where the student is doing her internship, there is a mentor over there who is also an examiner. That means their project in charge is also an examiner for that student. So the internship is not just for a certificate or just to complete it, but it is part of the academic program where the student is going to earn X number of credits, and that is going to reflect on his or her mark sheet. So we have seen that everyone needs a motivator to work. The motivator could be money, the motivator could be marks, the motivator could be career. Motivators could be several. But we noticed that more the motivators, the better it is. So students at our institute, they take internship very seriously because it's about their career, because they do an internship with the intention to get a job in that particular area, either in that company or some other company working on similar technologies. And also because they're going to get grades, marks associated for the work, they will take that seriously. So this is what we have seen. If you have multiple motivators like this, then everyone performs. Ultimately, carrot and stick, as they say, right? You need something to ensure that people perform. And about Raghu's point earlier, I agree very much that he was talking about finishing schools and coming back in colleges. So what one thing we have done, where we actually need a lot of help from industry also, is what we have done is every course that a student does in college has a project with it. So student does a course on semiconductors in second year engineering, on VLSI in third year engineering. It's not that there is only a theory exam or the traditional way of assessing. It may be there, but will have very less weightage. There will be a substantial weightage to a project they will have to do. So I'm doing a course in VLSI in third year engineering. I have to deliver a project in VLSI. I have to do that. This besides my lab. It's besides the theory courses, the tutorials I attend, and that has a substantial weightage in the assessment of the course. So we have seen steps like these actually motivate the student to go deeper into the subject and so on. So here is one area where we are working with the industry, because we saw that just going to the industry and saying that, hey, take our students as interns or jobs, that just seems one thing. So we are actually trying to work with several industry to get problems which students can use to deliver their projects during the course. Especially in the IT area, perhaps there are sufficient problems that come up because of the nature of the work. Suppose I'm doing a course in object-oriented programming, Java. I can get several ideas to deliver a course project. But especially when it comes to manufacturing, when it comes to semiconductor industry, VLSI, etc., we are actually looking forward to engage with the industry to get more ideas on board for our students to deliver projects. So these are 2 points.
Raghu, you think that working with institutions and setting up centers of excellence is a much better investment compared to taking somebody and training them in your premise? Would that be an outlook? What is the industry outlook on that?
So just to take a leaf from what Sir mentioned, let's say an organization, let's say the two leaders here, they run divisions, right? If within our organization, let's take only 15 people and give them a job of saying that adopt your college, right? So we all have studied in different colleges, right? So if I adopt a college that I have come from, it is my alma mater, I want to do something. So you see 15 colleges are taken care. He will do a program that we all talk, like your college, his college. So, then the chain continues. Now, just to take an example of what you mentioned, should we have a center of excellence or not? It's always good to catch them young, put the center of excellence within the college. They get benefited out of it. They get trained. They do projects. We train the professors and lecturers because they need to be also updated, right? The best in class technology which has been now talked about, the chiplet and 2.5 3D and all that stuff. The professor should know it because they should not be, I'm sure digital integrated circuits, the gates and NAND gates and the implementation still remain the same, right? But then they have to also start, op amps are still the same. But then if they have to teach the students with all the latest and the greatest tools, they should also be exposed to what the industry is talking about. So that's when, if you adopt a college, you go to the college, give a lecture, give them a one-day program to see what is happening in the industry, a mix of that. So put a center of excellence, adopt your college, make sure the college goes through the experiences of what the center of excellence is. Then the combination of, I like the idea of, 2 years studying, 1 year in center of excellence, the fourth year in the industry. You become a well-rounded person to understand, and then you get into the industry. I think some of these should be now mandated. Like now, AICT is at least now brought in a program, BTech in VLSI, because all these years it was electronics. Right now we have a separate stream for VLSI and semiconductor. So at least now, when a student learns 4 years, he will not go to do Java and all that stuff. Otherwise, they have all the options to 4 years
also
semiconductor. They will go
Talking
and
about the bulk of the population that
yeah,
studies
yeah,
EC. So now I come back to Deepak and Harshad again. So what are the significant breakthroughs that you see, Deepak, in the semiconductor industry in the next decade? Or I'm not asking what Intel is working on, but you can tell me what are the things that you see forthcoming.
Yeah, I don't have a crystal ball to see the future, right? I hope AI gives us a good crystal ball in next decade or two, right? But what I can talk about is the problem areas and the emerging use cases that will drive innovation in the semiconductor industry, right? So if we talked about the current trends, right? And then if you see in the last 5 years, the connected devices have grown by 4x or so, and in next decade, people are saying that the connected devices may grow to 15x or so, by 15x, in next decade or so. So semiconductors have become part of our life. I call it as our basic needs are roti kapda makan, and now with semiconductors it's like roti kapda makan and chips. That's our basic needs. So
That's right.
yeah, so some of the emerging
Naveen,
use
the chip,
cases.
I think we're talking about another chip.
No,
The chip that we both are interested in is a little.
And here I'm talking about
Yeah,
semiconductor chips.
yeah.
It's
I
part
mean,
of our life. Such a basic need it is. That's what
yes,
I'm trying
yes,
to say.
yeah. I got it. I mean, you are worried about the real lays and other chips. I am worried about
I was
the
wondering.
SOCs for sure.
Yeah. So some of the use cases, if I were to discuss, right? So the digital twins and the metaverse in the industrial IoT, right? Digital twins where you feed the data from production line or the equipment to your virtual virtual screen and the desk, right? So you are able to predictively predict the failure of the equipment, or do the predictive maintenance of your equipment or the production line, right? So that's digital twin. The metaverse is like, you can build the prototype of the next equipment or the next device you want to build physically. You can build it in the virtual world, right? So this kind of use cases and the growth of the connected devices, right, it's generating massive amount of data, and this massive amount of data is like a new oil today. And to handle this new oil, we need better, faster and cheaper chips, basically, right? So in the past, the power performance area and the cost has been the driving vector for the semiconductors. That will remain same, and it will continue to be a key vector for driving innovations in the semiconductors, right? So if I were to divide the problems and the emerging use cases driving the innovation in this industry, I'll to simplify, I'll categorize into three pieces, right? The process, the EDA tools and the products, right? So talking about the process, the Moore's law will continue, as Pat Gelsinger says, industry will continue to innovate and evolve Moore's law, implementation of Moore's law, until we are exhausting the periodic table. So that will continue in the next decade, or even beyond the decade, right? The second piece is, as we talked about the heterogeneous architecture and CPU, GPU, accelerators and everything on the same board, right? And that is increasing the complexity of the chip development by 100x, right? So to handle that kind of a complexity and develop those chips faster, right, for with different variants of the chips, we need significant innovations in EDA, right? So EDA will adopt AI and ML techniques at every stage of the chip development flow, whether it's a front end design, it's a verification, testing, debug, So that's where the lot of innovation will happen in the EDA industry. Coming to the last part, the products, right? So with heterogeneous architecture and enterprises requiring their data to be analyzed, their business critical data to be analyzed locally. So there will be edge servers, and they will require their AI algorithm specific, domain specific accelerators to be attached to the x86 kind of edge server, right? So like Naveen was talking about, he's building a modular TV, right? So edge server, yeah. So it's like you have a main CPU, and then you want to have acceleration, and you can have accelerator closer to the CPU attached using the CXL, right? So you will see a lot of domain specific accelerators coming up, right? And the AI PC kind of use cases, right, where AI reaches to the mass population, and then we talk about huge power consumption in AI training at the data center, and it's causing a lot of greenhouse gas emissions, right? So it will require a lot of innovations there to do the AI training at efficiently. But we cannot ignore the AI inference, because as the AI reaches mass population, and then inference would be done more frequently in millions of AI devices. So that will remain another critical factor to look into for innovating, right? The AI PC NPU performance need, or the performance demand, will keep growing, and that too at reduced power, right? So I see there is a bright future, basically. We have so many exciting things coming up, and in the longer term, if you see, to meet the compute performance demand, we may see a lot of progress on quantum computing and quantum computing integration with the traditional semiconductor, right? And we may see like novel architectures like neuromorphic computing, the brain inspired computing architectures coming, or getting commercialized, and non-conventional architectures coming up in next decade or so.
Got it. That is, you know, kind of where, we are seeing a universe where every item that we use is a computer in itself, which is all kind of connected. And then, so I see that happening in a very, very, low latent level right now. But I believe, there'll be a, like everything, right from your, even your gas stove, air fryer to washing machine, dishwasher, everything connected. And then, you switch it, turn it on, turn it off from wherever you are. It's happening today. But then, when you talk about, industry specific accelerators added to these chips, probably this will kind of make IoT the future of it, I believe. And Harshad, coming back to you, now all these things are connected, networked. So where do you see Juniper growing and ensuring that all these networking things are covered?
Right. So Deepak covered a lot of good points. So I'll talk only about the connectivity part. We are seeing 5G already, right? Because when we say all these devices are going to be connected, they're mostly going to be through 5G, and 5G is not going to be enough. So we are going to 6G, and that will enable the concept which we don't have today, which the 6G standard working on, is to give a very good latency behavior on a telecom network. Now, this all is going to put a lot of challenges on the edge routers and the core routers of the service providers. So I see a lot of innovation happening there. Newer devices coming there, which could be enabling these services. Something like any virtual game you want to participate, and you are doing on a 5G or a 6G network. The latency becomes critical, and it becomes critical, and it's to be tuned across the network. So it's not only about your connection. The other part which Raghu just mentioned once is the co-packaged optics. It may happen, it may not happen. So the industry is trying to figuring that out. Because when so many 6G connection comes in, the capacity of the router also has to grow by 10x. So how do you connect all these chips at such a high rate? Third part Deepak talked about is how do you cool these things, right? And people are already talking about immersion cooling, right? We are only doing air cooling today, and that is not sufficient. Uh, People are even talking of breaking a box, a traditional chassis into a distributed chassis. So a lot of ideas people are trying. This would evolve into more complex system getting built, because now your approach will change. You break it out just to cool it, because someone may not be very comfortable with immersion cooling, because then you have to put a new infrastructure for doing that. So next decade, compute and network both are going to grow, because it's not no more only the western world using the compute, right? It's all the Indians, Chinese. So the amount of data which is going to come into the networks, getting routed, getting used, it's just going to explode more and more, because now people are onto it, right? So they're going to build more use cases. So this is going to grow to a 2x, 4x level in next decade very easily. So we all have to be geared up for it, and we are building systems which would be uh, which would fit into this matrix of power, uh, price eventually, and performance.
Got it.
And also size matters. Uh,
True.
for the modular design, if the size is so big, then how do you integrate it, right?
Exactly.
So
Exactly.
They have a very, nomenclature of PPA,
Yeah.
price performance in area.
Yeah. Yeah.
So that's what the designers look at.
Right.
When you are hiring talent, right, would you like somebody who has spent say 5 6 years in semiconductor electronics and is kind of outdated? Would you like that person, and then kind of reskill and upskill, like what TCS is doing today, saying that 100% of their workforce is AI trained? I don't know what that means. And or else would you rather have somebody fresh who does not have any preconceived notions about the industry and train them? What is your perfect bet?
if you specifically ask me, I wouldn't take either of them. Neither freshers, neither experienced. We need people who could learn and who have basic ideas at least, because you cannot bring in an honors guy and start showing him about semiconductors and start training him about semiconductors. It's not possible. We need people who have basic idea about electronics. We need people who have basic idea about starting the alphabet. They know the alphabet of semiconductors. These are the people whom we need, whom we can train on. And also it's about learning capabilities, right? People whom we are taking in, they have to adapt to newer technologies every single day, because the way we are growing in semiconductor industry is too fast. I wouldn't hire a really expert guy into certain positions, because I'm sure I need to achieve newer goals rather than going back and sticking back to the loop. But whereas in certain positions, if it's like, let's say if it is in fab design and other things, I would definitely say I would go for an experienced guy. But in the state that we are in at Ridex, I'm not going for neither expert, neither fresher. I need someone who has basics of understanding. Then I would bring in an expert and get him trained.
Got it. Raghu, you are the man, who's, hiring 800 people in the next 1 year and trying to grow Keynes into a bigger manufacturing giant than what it is today. Already, it is a giant. So, what is your take on that freshers versus experienced people but outdated?
So from our side, we need a mix of both. Rather, we will go one step differently. Is that engineering community is good, but I need a lot of diploma holders. I need a lot of ITI graduates and NTTF people who have gone through that, because I need technicians. I need people to run my plant, right? And so, equipment guys, maintenance guys. I need a different segment of people, different functions. I need a mechanical engineer because he would look at lead frame design. I would need chemical engineers because we would be deploying a lot of gases. I need material science guys because I would be looking at different kinds of materials when I put my R&D. I need people who come with data science experience because I'm looking at a machine to machine communication. How is the data going from one machine to another machine, right? So this looks a little futuristic, but to start with, I would look at diploma graduates and engineers, right? Mix of this, and then I add in other functions as I move forward. Because manufacturing now will look at different other substrate design, package design, then package manufacturing. So I'm hoping that this would be an interesting next 3 to 4 years as we go and develop with, I'm talking to NTTF, various NTTF, I'm talking to ITI, I'm talking to diploma graduates in multiple of these functions and bring them, build them, see how they can run the factory. I'm looking at, we already hired 10 ladies from Telangana, because we believe that there are certain functions like quality inspection are best done by them, because they are very focused, not trying to bring a gender bias here, but we have seen that, you know not that heavy lifting they cannot do, but certain functions they will do it. If it was to me, like Ola put up a plant in Krishnagiri which is all women run, we would want to have a larger diversity within our organization. So I'm going to do a mix of all this, because at this point in time I can experiment a lot, because there is no fixed rule here now. He has done this, I have to do this. So I'm going to do some of these, put an R&D team, because manufacturing needs, when I go to a customer, let's say I come to Intel, I come to Juniper is a system guy. I go to Intel and then say that, give me some of your packages that I will do it here. The first question is that, what kind of an experience, what have you done? With everything the same, which means yield, quality, process is the same, which Intel will compare me with their factories in Southeast Asia. The next best would be the price and the systems that I've put in the organization. So, some of these manufacturing guys need to look at all this as they go and start to hire people. If you would have read us, Tata is looking to hire people from Taiwan. We are looking at Malaysia and Philippines, because we believe that there are some trained manpower over there who will come as an expat for the next 4 or 5 years, build this, run for us, train our people, and then move out. And by the time we would have our own expertise built up. So I would see a mix of both, like you were saying.
Got it. So Deepak, if like the candidates I told, comes to you for an interview, one an experienced but a little outdated candidate, but then another one a fresher with a lot of energy. What kind of person would you interview? They talked about it from a business angle. You talk about it just from a decision making point of view, with assuming you know this is a decision you'll have to make.
Right. Yeah. No. So few weeks back, our Intel India president Gokul was talking to all of us leaders, and what he told us is that don't hire people like you. You hire people who are different from you. That's the guideline that he's asking us to keep in mind while hiring, right? So we would want to hire experienced people as well as freshers, what is more important to me is that the person has the learning attitude. Basically, if he's a quick learner, that is important. We understand that colleges have one curriculum and one syllabus, and then industry is far ahead in developing a lot of state of the art chips, right? So we don't expect that they will have all the advanced skills, right, and the knowledge about that. We can always train them. What is required is right learning attitude in the person, right, if it is a fresher, basically. Yeah.
Got it. Harshad, your thoughts on that?
Yeah, so add to what Deepak said, right? So first it depends on the role for which I am hiring, whether I need a experienced person or I need a fresher. But for both the candidates, as Deepak said, the learning ability and the enthusiasm with which the person wants to do the job. Okay, you try to assess that. You try to assess the attitude of the person, whether he's a good team player, whether he can, if it's experience, then whether he can lead something, his communication skills. But in both these cases, and for our industry, and all of four of us will agree on this, is that the basic skills, what he mentioned a little bit while, the basics of electronics, and I am focused into digital electronics, uh, those don't go away, and that your foundation has to be very strong, whether you're a fresher, whether you're experienced. So that's the first mark we try to assess, that whether that person has that basic concepts or not. And then based on the level of experience, we expect he would have done something, and that's something how he's executed it. And nothing like you're talking about. Some people may write more in their resume than what they have done, right? So you're trying to find out how candid the person is. That okay, I may not have done that, but then you try to see that, oh, he may not have done that, but does he know that? Because if you've given a task, are you enthusiased to know what the task is doing? You may be contributing a little bit, but you learn all about that task. Okay, learn about all the product. So these are the characteristics I normally look out for both the freshers, because even if freshers in today's world, if the fresher know he's going for an interview with Juniper, I may expect him to at least know what Juniper is doing. All the information is available, whichever at least available in the public domain. Now, if the candidate at least needs to show some interest about he's knowing what Juniper is doing. So these are the characteristics I try to look at the candidates. But the basics is the first thing. The electronics basic has to be there.
There is one more point that I crucially consider for technical hiring. That is what kind of projects they have done, right? That's a gauging point for me. For all technical roles, when I take interviews, I'll just ask them, what did you do for your projects? That's when we will be able to understand whether this person, his learning skills are there. I mean, he can learn things, but how can he experiment with the ideas, and how can he work on his ideas is also very important, because end of the day, learning and execution, both of them are equally important. If a person learns, he will keep learning, but if he's unable to execute it, then it's a problem, right? So we have to look at what are the patterns of that person. If he has done something which is related to the industry, it's very important. So projects, I would definitely recommend people doing great projects there.
Okay. So, kind of, adding on to what Deepak said, right? So there is like, say, the industry is, light years ahead of academia, and there is a lot of gap to bridge between the industry and academia. And, also the finishing schools that Raghu talked about, where, it's like a crash course where at least they get up to speed, know the basics and all of that. So where do you think the industry and academia could collaborate, you know with expecting the least the government could do to facilitate this, and not put in more restrictions on top of this? What do you think the industry and academia could collaborate to make this talent as close to hitting the ground running as possible? What do you think, Deepak?
Yeah, I like one recent initiative by UGC, right? That is Professor of Practice, right? So which allows industry experts to come and engage with the institutions, right? So that's a very significant step, I would say. They have initiated. It will help in reducing this wide gap that we are seeing between the institutes and the industry, right? So institutes definitely should collaborate with industries, and make sure that the experts come to the institute, they either mentor the students with their projects, and they either mentor the projects, or they give lectures, and the trends, the way we talked about some trends and the problem areas, right? They talk about those things, so that students can venture into different research areas and then build their skills and the knowledge, right? They come and give the seminars, right? So those are the kind of things would help in reducing this gap, I feel.
So this is a very important thing what you mentioned now. You know, if you look at people from industry are quitting their job and going to education institutes to teach. Because that is open now. They can become professors after you have a certain number of years. See, the reverse should also happen. The professors and the lecturers should come to the industry. They should come and see. I mean, rather when I go, I invite them to come and see what is manufacturing happening. Instead of sending the students, you guys should also come. Come and spend time to look at what kind of a manufacturing processes we're doing. So then when you spend time, you go back and be an effective teacher, or update and stuff like that. So the professors should come, spend some time in the industry along with students. Then you get a little bit of an experience of what you should go back and teach. So that's a very good point which UGC started and you brought about.
It's a lot of synergy exchange. I mean, just students does not matter. Even we need professors and all coming in. That's
So
really
especially
the
I
point
think
is
in
very good.
especially our field, there's a lot of gap. Maybe software or application software. I would use software in a very different way. In application software, there's not that much gap because it's easier to learn. But if I talk about system software, he talked a little bit about writing firmwares. Okay, we have divided software in a lot of fields, but see what is firmware, right? You're writing something on a chip. There's an initialization sequence, right? Uh, Students getting too much into all this application software mode. And what we're talking about, which we're missing in India, is the core technologies, which actually builds a system, which could be taking a chip, building a PCB, and how the PCB is built. Maybe second year student can do that as a project in the college. I did that in VIT. I've designed my own PCB, put 10 chips, it did not work. Okay, but the amount of learning we went through, okay, was massive. I talk with a lot of recent engineers in whatever we hire, and very few have done that in recent past. Very few have actually done a PCB design by their hand. All the tools are available. We had a very bad 1997 PC, if you remember, and a very bad Mentor graphics software, which was like without any license, right? What will you do? But if you don't do that, okay, and same applies to device driver development. If you don't do device driver development, you'll not understand basics of OS. You'll not understand things about kernel. Somehow we need to get into that. We need to get students driven for doing things like that. Things like basic PCB design, system software, right? Application software can be learned later. But these two parts we are missing. It becomes very difficult to hire candidates with this background. There's a lot of places where you need engineers, and definitely Intel also needs it, who actually knows how to write a C code, but needs to know the chip to read the specification, how a chip is accessed. That is a very it's suddenly become a very specialized field. But engineers supposed to know that. If you are engineer, if you are electronics engineer, or if you're a computer engineer, I'm not saying computer science. If you're a computer engineer, you should know that as a computer engineer, there's some chip, there's some register space, and there's some way a hardware and software interact. This needs to be taught in the college, and students should strive to learn that. We are missing this piece. We are talking too much about application. We are talking too much about AI. We need to get students down to what actually is needed. Because if you're going to build all this electronic system in India, we need people who understand systems inside. You may not know chip design, but you know what chip can do. See, I work with tons of people who know what chip can do. They write very good device driver software. They understand how chip behaves. But to develop that skill, the student first needs to learn that software is not about some fancy Java environment and you're writing there. No, eventually it goes down on a chip, because then only you want to tune a performance, what it means. So somehow the courseware of a computer engineer and electronics engineer is missing this piece. Don't focus only on the application. Focus on databases, focus on kernels, focus on a processor or any ASIC interface. It doesn't need to be the design of the processor. So these are the skills we are missing. Then what happens is the student has to learn all that when they get into the job. When we joined CDAC, okay, in 2000, I was in CDAC after doing the VLSI course, and we developed a FPGA, and all of us were fresher, and we actually wrote the other two fresher actually wrote a device driver on a Linux in 2000. They were B graduate, they had no idea, but they learned on their own. They wrote it and it actually worked. Nowadays we call it a SmartNIC, but that was a SmartNIC in 2000. What we were doing? We were doing some kind of RDMA on FPGA, and we used to call it Paramnet. You get that opportunity, but see, they're very less. In coming future, India, you're going to get a lot of such opportunities. But are the students ready? Do they want to do that? First of all, do they know there's such opportunity exists and there's a lot of rewards to be made there? Instead of just talking about AI, talking about application software. So somehow we need to bring this into the academia that there's a lot to be done in system software, lot to be done in OS space, lot to be done in the chip level.
I think that can be done once we start, building something new rather than going back into the same old projects again. You see, there are ready-made projects. Pay 10,000 and you get a project. That's the point,
Yeah,
right?
true.
Uh, Educational institutions need to give a real creative projects to people. I mean, the kids, the engineering students, rather than giving them a choice that you choose which project you want to do and go ahead and start it. 10,000 mein aa jayega. I mean, that's what we need to stop. In fact, to achieve these kind of expectations.
Right, right.
So we give them a goal to achieve,
Right.
and people should work towards it to achieve rather than buying the already existing
True.
systems.
True.
I think that makes a
Yep,
bit of
yep,
change
yep.
over there.
I mean, if you allow them to fail, it's fine, right? Even if they fail, it's fine.
They have the experience.
Yeah, but they have the
matters.
experience. Yeah, and you give them grades because they actually originally did it. They could have done very basic mistakes, which is perfectly fine.
So I think, I mean, we had similar thing. We were actually designing a drone back in 2014. The drone used to fly. It used to fly and drop down. We never used to we were unable to maneuver it to go forward or backward. But still, we got the best marks because we did real experimenting with that. So this is
Okay.
my experience, like
Wow,
what
yeah,
we
yeah.
discussed.
Yeah.
Yeah, in fact, I take your point very much because I have also noticed this that in AI, object-oriented programming application, it's kind of easier also perhaps for most colleges to, adjust to what's happening currently, give projects in those areas.
Right.
But especially when it comes to system level things, semiconductors and so on, I agree that the technology has gone ahead a lot in that sense. And in some way, again, when we start teaching, even I graduated at the similar time like you were 1997. We did EDC, Millman Helkes, basic digital
Exactly.
electronics.
Yeah.
From there you start.
Yeah.
And then to think of the current technology which is
True.
there in systems area, that is a huge tall ask. So
Yeah.
I really think that this point, which Deepak mentioned about professor of practice, about having more industry courses, etc. We have had that experiment. I mean, I would say in the last 10 years in our college, maybe around a dozen or 2 dozen courses were taught by industry. And we noticed there was a lot of enthusiasm from students to join those electives. One, obviously, because it was a different segment of teachers coming to teach them.
Mhm.
It was offered by the industry in campus,
Mhm.
and many industries they also did. They combined a couple of colleges, and they would offer an elective.
Oh.
Which made it easier
Yeah,
for
yeah,
them
yeah.
also.
It's a
And
good
it was a
idea.
mix of online and offline. We had it that way. But the response was very good, and that learning was also very good. So I think all the gentlemen, the points that they have got, the point about sabbatical, about faculty also, time to time going to the industry and not just contributing over there, but to get themselves better enabled in terms of what is happening, in tune with that, and so on. This will go a long way in bridging these gaps.
Right.
Yeah, certainly.
True. If I kind of want to summarize all of this and then, put it like, in second year, they do industry projects where, marks is given for originality, not for performance, from the academia side. And then, following it up with a lot of talks from the industry where, people like Deepak, Raghu come and talk what is happening in the industry, and then then setting up centers of excellences where the industry sets it up, and then the third year there is a the student goes to the center of excellence every day, day in day out, and the center of excellence is driven by the industry's knowledge, but rather run on a day to day basis by the professor who has come and learned what is it from the industry. And then towards the final year they come for a 1 year internship, they work with you for 1 year, like you get a fresher working with you for 1 year, and at the end of the 1 year you hire him at a fresher salary, but technically you get a 1 year experience guy on your payroll. So that's where I see the fusion of like the Indo-Chinese thing, right? You can't eat Chinese, Indian is a different cuisine, but then Indo-Chinese has a flair to it. So that's where I see the industry academia coming in together, probably with more of industry leaders. How open is the industry looking at centers of excellences, or spending their CSR funds there, or putting in an effort towards this? Is the industry facing challenges because the academic institutions are not very cooperative or very very rigid, or is it that the industry does not have bandwidth to do this?
So, I mean, I see it more openness within the academia and industry. It is just that both of them did not come together as much it should have been. But I think in the last 4 to 5 years, with all these semiconductor news and government push, the subsidy to put manufacturing, all that is making sure that everybody wants now. The colleges and the university wants to up their ranking. They want to make sure that best of the students come there and study. They would want the Intel, Qualcomm, and Juniper to go there and hire so that their ranking improves and all that. So I think there's an all-round effort of and then a few of the colleges did program, right? VIT look at DFT. Intel went to Vellore Institute of Technology, put a DFT program, and started to hire niche DFT guys from there and all that. So things are happening. Center of excellences, like you spoke of. Somebody's looking at analog, somebody's looking at digital. Some of these, companies like Sankalp Semiconductor, all going to, cities which are non-Bangalore, non-Hyderabad, non-Noida. They went to Hubli, they went to Bhubaneswar, they went to Indore. I think all these are now helping that, the semiconductor or VLSI as a technology goes to other colleges which are non these four centers. So,
Right now, what are you doing at Keynes? Do you think the industry should do absorb more of, or what would you like to do at Keynes that probably due to rigidity or budgetary constraints or bandwidth you're not able to do something?
what happened in the design part was necessitated because the tools were available. And in the entire process, that was the highest cost item. The academia was willing to put a infrastructure or the real estate because they have huge real estate. So putting a lab was very easy. They can give spaces. They can give lecturers and professors to come and teach. People from outside go create course curriculum. But the important thing was to have the tools available because tools are very, very costly. The Intel and Junipers get it at a much better price because they buy in volumes, right? But from an academic standpoint, that was tough, which the government solved that problem because they bought it at a price and then subsidized price and gave it to them. Now the challenge is to put the equipment because you cannot teach manufacturing by some course curriculum did for 6 weeks or time. You need a hands-on experience. This is equipment. So now to get the equipment from the best-in-class equipment guys, to teach interconnect technology or wire bond, I cannot just show in a video and show in theory. I have to really show it in the equipment, right? So those are costly equipments, which means that some of these equipment guys have to give us a depreciated equipment or need to use some of the CSR funds and these equipments. And these need to be a set of equipments. It's not one equipment. A manufacturing process like the VLSI has a steps. So manufacturing also has steps. All these equipment guys need to come together, either government funds, industry funds, or the education institutes funds use the CSR money, and these equipment needs to be laid down. Then clean room, because unlike the design, you don't need a class X clean room there. Here you need clean rooms because these processes need to, otherwise contamination and all that stuff. So clean room, equipments, then train manpower. Who will run this? Because if I have to teach an engineer at a college, I need people who are trained to do that, right? So we need to get some people from outside to come and run this program. Then course curriculum. It's a little easier because there are expats or people from outside can come. So we are trying to, fix one of these and see how we can bring together all, at least run one center of excellence in the next couple of months, and then get people out and say, the first batch of 30 people have been trained hands-on for a 6 months program. I think that will be an achievement if we do it in the next 6 to 8 months. And then, wherever engineers go is not that matter. But we'll hire a lot. We'll give it to the industry also.
I think the combination of both of what we told would work really well. I told there has to be a year dedicated for the semiconductor technology itself. Whereas just immediately after that, you have people who are going to the center of excellence and learning these things in clean rooms. That will boost a lot. It has to be a combination of both together, theory as well as the practical side.
Then what is my charter to grow business, to generate revenue, right? So that's my charter. How much will I do this? So I need partners who are willing to pick this up and work along with us. And should we do that, or should we look at some of the finishing schools, do an extension there, because they've already done design, right? So get them to look at manufacturing. So I think many of these ideas needs to work, and then we're working with India Electronic Semiconductor Association, IESA. They have a Campus Connect program run by Mr. Pradeep Thakkar over there, and so some of these guys needs to come together and do whatever is required for manufacturing.
So, Deepak, what do you think Intel is doing these days, you know, to, get as best talent from the industry as possible? You joined them from VIT, IIT Bombay, you joined them straight. So, today, how is Intel hiring, and what kind of talent are they looking for?
Yeah, so we have a dedicated university engagement team, right? So I'm neck deep involved with my work, so I'll not be able to give any inputs on that. Basically, you may want to I would say VIT to get in touch with our university engagement team and then find out more about that.
Okay, got it. Harshad, the same question goes to you. I want a different answer this time.
Okay, so I'm in the same boat as Deepak. But what I know is we have a very good 6 months program where we hire from the from the universities, from the colleges, from few colleges, and then the trainee works for us in the fourth semester. The entire semester it works. So
Fourth semester or fourth year?
fourth year, no, 6 months only. The eighth semester.
Eighth semester.
Eighth
Yeah.
semester.
Eighth semester.
And then we get an opportunity to assess the person. So 6 months is pretty good program. That's the only engagement which I know what Juniper is doing. More information from Juniper HR. I think we talked about it earlier.
Yes, Naveen, you're going to put a futuristic TV COE so that you get better engineers, or what do you think? When I said, when, Raghu was talking about the center of excellence, electronics knowledge, and then 1 year your eyes kind of lit up, So I wanted to understand and specifically pick on, what is that you think, because everybody is, they both belong to Giant, and then he owns a Giant, but then, he has the, levers to pull along, whereas, you're very agile. What is something that you would do, one magic thing tomorrow that will, solve your problem day after tomorrow?
See, we have certain challenges. We are not into the core of the entire semiconductor industry. We are the users of them, right? The people that we pick are totally different than the people they try to pick. So we want very good people who are good at testing, and we look at people who are very good at building the right firmwares for us, for the SOCs. I see there is a great future because in future televisions, till now televisions have been one-way communication devices, right? So the cable network is connected. TVs will show based on the channel you switch. But now it's changing. As you said, IoT, Internet of Things, right? So now television has become the epicenter of the entire home. It's the center of the home. You can offload a lot of your applications from your mobile phone to your TV, such as IoT applications that controls your automatic washing machines or your lights and everything. That's where we need people who could test and write firmwares for all of these, right? So I think uh, if you are asking me, right, like how would I mean, how would I want Ridex to be contributing in terms of getting better people out of the colleges is by partnering with other organizations where we could build a center of excellence, and then we would choose the right people who are well suitable for our roles and go ahead with that. That's what I think.
Got it. So, Karthik, coming back to you, you've heard from these folks. What do you think is, that, let's say, you would like to do as an institution, kind of, cater to the industry demands and, kind of bridge the gap as well?
Yeah. So as especially in the last round of discussion, which Raghu, Deepak, Naveen, all of them were saying, Harshad as well. I realized that I said it earlier as well. We need to especially in core areas of engineering to work more on the quality of student work that happens over the 4 years. So at Vishwakarma, we have a very good we have very good systems in place in terms of projects, and we have had very good success in several areas. So just to add to one point Naveen was saying, like projects. So I was saying earlier, right, with every course a student has to do a project, and we started another initiative recently which was very unique to us. So what we did is, in every semester, suppose there are 5 courses, student will do a project in each of the 5, plus there is a 6th course which is only a project, where the student can take up any project of his or her choice and study whatever technologies are needed around that and build it up. So right, so the previous ones were all course centric, so project based on a course, but now this is project centric, so the project is the center, and you may have not learned that particular course in that particular semester, but you need to bring in that knowledge and do. So we have had this is a new thing that we actually started. I don't think such courses exist anywhere. And we noticed that students are doing very well, and as Naveen was saying, many companies have noticed when they come for interviewing students, most of the time the most important question they ask us, tell us the projects that you have done. Naveen was making the point. So in that we have seen that many of our students tend to do well, because of this framework that we have. But at the same time, I realized that especially in core engineering areas, we are already working, but we need to add more industry association with the college, where we get good quality problems to work on. Because as Harshad was saying earlier, in application Java, AI, it's by and large easier to get very good ideas just sitting on your laptop. But in core areas of engineering, that is one area which we need to work. And I'm sure that with not only with all these gentlemen, but in general with the semiconductor industry, we would like to increase that affiliation to enhance the quality of projects, which I think will go a long way in improving the kind of graduates that come out at the end of the 4-year course.
So if we have to, have some tangible outputs that come out of this podcast, rather than exchanging ideas and stuff like that. One comment I would like: we've invested in a company called Mixtech, which is doing silicon photonics and co-package optics. So it'll be sooner than later that there's a co-package optics chip coming out of India, which means the VLSI know-how would reside in India, patent in India, the process know-how would be done in India, and then a line would be set up to do co-package optics. So company to look out is Mixed Technology, and those are the guys who came out from Intel, who's done silicon photonics and Broadcom and stuff like that. So that's one thing which we are doing. And if suppose this has to go on a note where there are tangible benefits, and we are willing to come and work with the institute and put a center of excellence in the semiconductor package, honestly. And if the university or the institutes is welcoming us, trainer, course curriculum, help to bring these equipment guys together and put a line over there, a clean room and stuff like that. If that's something that is
Oh, sure.
you know,
Very much
interest to you,
interested. Yeah.
And we can
we could come
probably
there.
give some projects for
There you
the
go.
people.
Sure.
Just one thought came to, it's a radical thought. You may want to, think about it, right? So, one good thing institutes have is, you have so many students, coming every year. You have, so many students, right?
A lot of energy.
Lot of energy, lot of enthusiasm and young blood, right? And lot of enthusiasm to, do something different for the world, right? So I'm thinking, what if you create ground up educational processor core. See, one group of students builds the instruction decoder, one group of students builds the execution unit, one group of students works on caches. So you start with very basic thing. We know that students will not be able to come out with something useful, but it's just for the educational purpose to build the relevant skills to the industry. So you look at IEEE papers related to caches basically, right? And you identify the problems. You build very basic core. Different group of students builds a different core, different pieces on the core. You keep that live from generation to generation of the students. Let the students tinker with that. It's kind of a tinkering lab for the processor development. That's one example. You could pick up GPU, or you could pick up accelerator, depending on whichever area you want to build on, right? So some group of students basically say they integrate and then they verify the thing. Some group of students build the corner case test cases. They think about the test cases. Your computer science students could build applications that could run on this this tinkering lab generated processor core, right? And that's somehow you can see if you can evolve that and keep it live for generation of students, right? Second year students, they can start learning about it. They understand what is there in the that is already built in. They give seminars to their senior students, you know and see if you can evolve that basically. And then as you build this thing, students will start getting ideas, where the bottlenecks are, what I need to learn about. So the side benefit of that would be, when they appear for interview, they have already gone through some basic cycle of developing something useful.
I think a very good takeaway point for me that the projects they do, it has to be iterative in this
Yeah,
fashion.
they
They
operate
work
as a
on,
corporate,
yeah,
and then they
yes,
get the experience of how to work in the teams, how to
yes,
contribute to the team's goals
and they
basically.
keep adding to whatever has already been done
Done. And then you
rather than
understand
starting
that,
from
because
scratch
that's what,
always.
when you join the industry, you have to understand lot of existing design. That
Yes,
understanding the existing complex design, it requires a different set of skill. So that way you start from say
100%.
second year, they understand the code written, they just simulate it, run existing test. You may require some project staff that is permanently trying to maintain this kind of a project from generation of students to generation of students, right? Different generations.
This is a great idea. I mean,
Yeah, just to add to Deepak's idea, like Risk 5 was built like
I was
that by
about to
David.
tell that. IIT
IIT
Chennai,
Madras.
Yeah,
IIT
yeah,
Chennai
yeah.
Yeah.
did a
And
Shakti
it's
processor got built
Shakti is
after
like
this.
that,
Exactly.
but it's open source,
It's
and
an
you
open
can
source.
still do that. So it's a very good
I
idea.
didn't want
Yeah.
to bring in the Risk 5 at all, because then you get into Risk 5 ARM, Intel, and all that.
we are currently experimenting with those for our.
I would say it's time to go now.
Yeah, but one additional suggestion, like I don't know, I've not visited the VIT labs. Do you have the FPGA based boards where students can actually implement some designs and see what they're doing? So
Yes,
it
yes,
could
we
be
do have, we do
okay,
have.
okay. And students are
Yeah.
doing that. Students are
Yes, yes.
actually
It's part of their VLSI course actually.
okay, okay,
Yeah.
okay. Okay. Then this kind of
Sure.
projects
Yeah,
are
we
very
can do
very
that.
good thing.
I would want to take it back to my
yeah,
college. Yeah, sure.
yeah.
We can give you the end use cases.
Sure, sure.
Because
Actually,
that's what we need.
use cases is something that we will look for industry and any.
Out of the IIT Chennai, even though Professor Kamakoti and team were looking at the Risk 5 stuff, there came an IP company called
Yeah.
In-Core Semi.
In course. Yeah.
Then there a end product company came out called Mindgroove, which is, In-Core anyway moved out, and Mindgroove is still within IIT Chennai. So these are good ideas
Yeah.
that we should do.
Fantastic. I was, I've gone from K1 in semiconductors to graduation today, and I have a lot of buzzwords that I, just flew over my head that I'll have to go and do a lot of research. But it was fantastic. I actually, I like the initiative that Raghu put across, saying that it's not just, confluence of ideas, that has to be something tangible. which is benefiting the academy as well. So, and Karthik's openness to kind of quickly pick on these things, and fantastic discussion. Thank you all very much for making this happening. This is our inaugural edition. We'll keep you all posted on the next set of editions. We'll be calling people from diverse industries, AI, data science, computer science, product development, semiconductor, so manufacturing, mechanical, a lot of these things that you were talking about, material science and all of that. So we want to bring in a lot of industry veterans and stalwart stock. That's why we consider all of you as titans in your industry. That's why we've named it Titan Stock. Thank you very much. Thank you very much.
Thank you. Thanks a lot.
Thank you.
Thank you for getting. Thank you.
Hey, thanks for watching Titan Talk today. I hope you had a really insightful session. I'm Gautam, your global CHRO who helps you buy, build, and rent talent across industries, across levels of experience. If you want to hire freshers or if you want to hire laterals, do get in touch with us with the link below, and my team will get in touch with you to take it from there. Looking forward to meeting you again in another episode.